Good evening, everyone. Welcome to week 10 problem solving session. Today I'll be discussing questions related to week 10 lecture materials and assignment solution. So let's start. The first question is the reaction of PCl5 with P4O10 leads to the formation of option A PO3Cl, option B PO2Cl2, option C POCl3, and option D PO2 and Cl2. So this reaction of PCl5 with P4O10 is a method to synthesize POCl3. So the reaction is P4O10 plus 6 PCl5 will give 10 POCl3. So the answer is option C. PCl5 with P4O10 will give POCl3. So the other reaction of PCl5 are with reaction with alcohols ROS, it will give alkyl halides RCl, and with water it will give H3PO3 or POCl3. Depending upon the reaction conditions, products vary. And with KHF2, KPF6 is produced. KHF2 is a fluorinating agent. And with ASF3, PCl4, PCl6 complex is formed, cation and anions, ASF3, which is fluorinating agent. So it will form PCl4 cation and PF6 anion. And reaction with NH4Cl, it will give phosphazines. And the reaction with P4O10 gives POCl3. Reaction with BCl3 gives PCl4 and BCl4 complex. And the last one is with N2H4 gives Cl3, P double bond N, and double bond PCl3. The second question is the number of bridging SBF, SB and terminal SBF fluorine atoms in Sb2F7 minus respectively are. Option A is 1 and 6, option B is 2 and 5, option C is 3 and 4, and option D is 4 and 3. So SbF3 react with alkali metal fluorides to form various salts such as SbF5 2 minus, SbF4 minus, SB4 F16 4 minus, and FB2 F7 minus. So the product we are asked to find is Sb2F7. So the structure for Sb2F7 is like this. One antimony is having 3 terminal fluorides and one SbF FSB bridge is present. So the question is number of bridging FSB bonds. So only one FSB bond is present here, and terminal SBF. So there are 1, 2, 3, 4, 5, and 6 terminal fluorides are present, and one FSB bond is present. So answer is option A, 1 and 6. So in SBF5 and SBF4 there are no bridging present because only one antimony is present. In SB4F16 4 minus there are 4 SB bridges present. One, this is the second one, this third one, and fourth. So here SBF SB is 4, and again here one antimony is bonded to 3 terminal fluorine. So there are 4 SB, and for each 3 is present. So its SBF terminals are 4 into 3, which is 12. The next question is hydrolysis of sodium sulfide Na2S and sodium telluride Na2Te produce respectively. Option A is NaSH and TeOH twice. Option B is Na2SO4 and H2Te. Option C is H2S and NaTeH. And option D is NaSH and H2Te. So hydrolysis of sodium sulfide Na2S plus H2O will produce NaSH and sodium hydroxide. And hydrolysis of telluride Na2Te plus H2O. So for tellurium, degree of hydrolysis is very high compared to sulfur. So it will be completely hydrolyzed to form H2Te and NaOH. So there should be 2 H2O, so 2 NaOH. So for sodium sulfide, NaSH is the hydrolysis product, and for Na2Te, H2Te is the product. So option D is the answer. Next question is the option showing all species containing only peroxide ions is option A is H2O2, KO2 and PbO2. Option B is BaO2, K2O2 and H2O2. Option C is BaO2, KO2 and NaO2. And option D is NaO2, H2O2 and PbO2. So peroxide ion is O2, 2 minus or O minus. And if it's O2 minus is oxide, and O minus 1 by 2 is superoxide. So here in H2O2, H2 is H is in +1 state. So 2H is present. So total will be +2. So overall here it should be 2 minus. So this one is peroxide, and in KO2, K is in plus 1, so this whole is minus 1, so this is not peroxide. And in PbO2, Pb is in plus 4, so O2 is in 2 minus state. So again, total will be 4 minus, so 1 oxygen is in 2 minus, so this is not a peroxide. And here BaO2 and barium is in plus 2, so overall charge here should be 2 minus, so this is a peroxide. And in K2O2, K is in plus 1 state, so 2K is present, so here it should be 2 minus, so this is again peroxide. And in H2O2, we know this H is in plus 1, so 2H is present, so here it should be 2 minus, so this is peroxide. Here barium plus 2, so O2 should be O2 2 minus, so peroxide. K is in plus 1 state, so O2 is in minus 1 state, so not a peroxide. Here sodium is in plus 1, O2 is in minus 1, so it's not a peroxide. So again plus 1 and minus 1, so not a peroxide. Plus 1 and so 2H, so 2 minus, so it's a peroxide. And Pb is in plus 4, so here 4 minus, so not a peroxide. So the answer is option B, where all oxygen is in peroxide state. The next question is, the thiosulfate ion is a very good complex agent for Ag plus, and sodium thiosulfate is commonly used in photography for removing uncharged AgBr. The reaction of silver bromide with sodium thiosulfate, that is Na2S2O3, gives option A is Na, AgS2O3 and sodium bromide. Option B is Na3, AgS2O3 twice and sodium bromide. And option C is Na5, AgS2O3 thrice and sodium bromide. And option D is Na7, AgS2O3 four times and sodium bromide. So the if you have watched the lecture video, it's explained there, where the reaction of AgBr plus 3 sodium thiosulfide will react with 1 silver bromide. So it will form Na5 Ag S2O3 3 times and sodium bromide. So the answer is option C, Na5 AgS2O3 thrice and sodium bromide. The next question is, reaction of sulfuric acid with PCl5 leads to the formation of, option A is S2O5Cl, PoCl2 and HCl. Option B is S2O5Cl, PoCl3 and HCl. Option C is Cl2SO2H, PO2, Cl2 and HCl. And option D is ClSO3H, PoCl3 and HCl. So we are asked for the reaction of sulfuric acid with PCl5. So sulfuric acid is H2SO4 and reaction with PCl5. So for a reaction, H2SO4 is S double bond O, OH and OH. So we can rewrite it as SO2 OH twice plus PCl5 giving so it will be ClSO3H plus POCl3 plus HCl. So here one OH will be replaced with a Cl, and that oxygen will be taken by the phosphorus, and one of the chlorine will be given to uh, hydrogen to form POCl3 and HCl. So the answer is option D, ClSO3H, POCl3 and HCl. Next question is sodium hydroxide react with fluorine F2 to form. Option A is O2F2, NAF and H2O. Option B is OF2, NAF and H2O. Option C is OF2, NaHF2 and H2O. And option D is O2F2, NaHF2 and H2O. So this method to synthesize OF2, so the reaction is 2 NaOH plus 2F2 giving OF2, 2NaF and water. So in OF2, oxygen is in plus oxidation state and fluorine is -1 oxidation state. So since fluorine is highly electronegative, that's why oxygen is in plus positive oxidation state. So the answer is option B, OF2, NaF and H2. The next question is the reaction of sulfur dichloride HCl2 with NaF leads to the formation of option A is H2F2, H2Cl2 and NaCl. Option B is SFO, H2Cl3 and NaCl. Option C is H2F2, H2Cl3 and NaCl. And option D is SFO, H2Cl2 and NaCl. So the reaction is 3HCl2 plus 4NaF will be given in acetonitrile at 350 Kelvin. It will produce SFO, S2Cl2 and NaCl. So here SF4 will be structure is S, will be having one lone pair, then fluorine. So it will be having seesaw structure. With sp3 hybridization. So sp3 comes when one lone pair and 4 bond pairs are present. So total steric number will be 5. So 5 hybrid orbital is required. So sp3 hybridization is taken place. Next question is S2F10 on heating at 420 Kelvin produces. Option A is S2F4 and SF6. Option B is SF4 and SF6. Option C is S2F2 and S2F4. Option D is SF4 and S2F6. So S2F10, it has the structure as uh, so this is the structure for S2F10. One S bond is present and each sulfur is bonded to 5 fluorine atoms. So when S2F4, S2F10 is heated at 420 Kelvin, it will form SF4 and SF6. So you can remember like a bond cleavage like this. So one of the fluorine will form bond with sulfur and SF4 and SF6 will be formed. So the answer is option B, SF4 and SF6 are formed when S2F10 is heated at 420 Kelvin. The next question is the reaction of pH3 with KNH2 in liquid ammonia leads to the formation of option A is K2PH and NH3. Option B is PNH2 thrice and NH3. Option C is KPH2 and NH3 and option D is KPNH2 thrice and NH3. So the reaction is pH3 plus KNH2 in liquid ammonia will form KPH2 and NH3. So K plus and NH2. So this K replaces one of the H and the H is given to NH2 minus. So K PH2 and NH2 plus H plus is formed, which is NH3. So option C is the answer. Next question is in ozone, the central atom uses option A is roughly sp2 orbitals for sigma bonding. Option B is sp orbitals for pi bonding only. Option C is sp3 orbitals for sigma bonding. And option D is p d z square bonding for both sigma and pi bonding. So in ozone, the structure is O. So the hybridization for central oxygen will be sp2 because two bond pairs and one lone pair is present. So so the answer will be roughly sp2 orbitals for sigma bonding. Next question is ozone is prepared by the reaction of silent electric discharge upon oxygen in an apparatus called ozonizer. The reaction is option A endothermic, option B exothermic, option C leads to the formation of O2 plus and option D leads to the dissociation of the O2 molecules. So the preparation reaction is 3 by 2 O2 will be giving O3 gas, and the enthalpy of formation is O3 gaseous at 298 Kelvin is found to be plus 142 kilojoule per mole. So the positive says it's endothermic. So the reaction of synthesis of ozone using oxygen is endothermic reaction. The next question is the stability of hydrates follows the order. Option A H2TE greater than H2SE greater than H2S greater than H2O. Option B is H2O greater than H2S greater than H2SE greater than H2TE. Option C is H2O equal to H2S greater than H2TE greater than H2SE. And option D is H2O greater than H2S less than H2SE greater than H2TE. So in group 16 hydrates, when we move down the group, the stability of hydrates decreases. So the order of elements is oxygen, sulfur, selenium, and tellurium. So the hydrate stability will be decreasing down the group. So this can be explained using the formation energies. So the formation energies are given here. For H2O, it's highly exothermic and the formation will be highly stable. So it's minus 241 kilojoule per mole. For H2S, it's still exothermic, but it's small. And in H2SE, it's positive value. And in H2T is highly positive, which is plus 154.4. So it states that the order will be stability order will be higher for elements on the top, and the stability decreases down the group. So the order will be H2O greater than H2S greater than H2SE greater than H2TE. So the answer is option B, H2O greater than H2S greater than H2SE greater than H2TE. The next question is tellurium on reaction with ASF5 in the presence of ASF3 gives. Option A is Te4 ASF6 6 times, and option B is Te8 ASF6 2 times. Option C is Te6 ASF6 4 times, and option D is Te8 ASFO 2 times. So this is a method for synthesis of cations, and the reaction will be 6 Te plus 6 ASF5 in the presence of ASF3 will give Te6 ASF6 4 times plus 2 ASF3. So this is the method for synthesis of Te6 4 plus cation. So the answer is option C, Te6 ASF6 4 times. The next question is the reaction in which hydrogen peroxide acts as a reducing agent is option A 2FeCl2 plus 2HCl plus H2O giving 2FeCl3 plus 2H2O. Option B is 2Hi plus H2O2 giving 2H2O plus I2. Option C is H2SO3 plus H2O2 giving H2SO4 plus H2O. And option D is Cl2 plus H2O2 giving 2HCl plus O2. So it's given as hydrogen peroxide acting as a reducing agent. So when hydrogen peroxide is a reducing agent, it gets oxidized. That means reducing agent will be oxidizing, and the oxidizing agent will be reduced. So here FeCl2 plus HCl plus H2O2 giving 2 FeCl3 plus H2O2, 2H2O. So here in FeCl2, ion is in +2 oxidation state because Cl is in -1. So 2 Cl is present. So it total will be 2 minus. So Fe is in +2 state. Here H is in +1 and Cl is in -1. And in H2O2, oxygen is in -1 state and H is in +1 state. So in FeCl3, ion will be in +3 state because chlorine is in -1, but 3 chlorine is present, so 3 minus. So to compensate that, Fe should be +3. And here oxygen is in 2 minus state. So oxygen from -1 it went to 2 minus. So it is reducing. So it's not a reducing agent. And also Fe is oxidized to Fe3 plus. So H2O2 is an oxidizing agent because oxidation number of ion increased from +2 to +3. So here H2O2 is oxidizing agent. And in 2Hi plus H2O2 giving H2O plus I2. Here H is in +1, I is in -1, H is in +1. So O2 2 minus. So oxygen is in -1 state. In H2O, oxygen is in 2 minus and hydrogen is in +1 and I is in 0 state. So from -1 oxidation state, it went to 0 oxidation state. So oxidation number increased from negative to 0. So here again H2O2 act as oxidizing agent. And here H2SO3 plus H2O2 giving H2SO4 and H2O. Here hydrogen is in +1 and oxygen is in 2 minus. So 3 oxygen is present. So total should be 6 minus, and 6 minus plus 2 plus will be 4 minus. So S is in 4 plus oxidation state, and in H2O2 oxygen is -1, hydrogen is +1, and in H2SO4 hydrogen is in +1, oxygen is in 2 minus. So 4 oxygen, so -8, -8 plus 2 +1, so that will be -6. So to compensate that, sulfur should be in +6, and hydrogen is in +1 and oxygen is in 2 minus. So here oxidation state of sulfur increased from 4 plus 2, 6 plus. So here again H2O2 is oxidizing agent. And next one is Cl2 plus H2O2 giving to HCl plus O2. Here chlorine is in zero oxidation state. H2O2 hydrogen in plus 1, oxygen in minus 1 oxidation state, and in HCl, H is in plus 1 and Cl is minus 1 state, and oxygen is in zero oxidation state. So here Cl from zero oxidation state it went to minus 1, so it's a reduction. So because it's a reduction, H2O2 is a reducing agent. So the answer is option D, Cl2 plus H2O2 giving to HCl plus O2. Here H2O2 acts as reducing agent. The next question is the option showing correct statement for S2F10 is option A is at 420 Kelvin it dissociates to give SF4 and SF6. Option B is on heating at 420 Kelvin it produces SF4 and S2F6. Option C is in the structure of S2F10 it has two bridging fluorine. Option D is S2F10 consists of one SS bond. So first we have to draw the structure for S2F10. So the structure is so this is the structure for S2F10. So first statement was at 420 Kelvin dissociate to give SF4 and SF6. So we have already seen this question. So the statement is true. S2F10 on heating at 420 Kelvin will form S2, uh, SF4 and SF6. So the first statement is correct. Next one is on heating at 420 Kelvin, it produces SF4 and S2F6. So the statement is incorrect because it forms only SF6, not S2F6. The next option was in the structure S2F10, it has two bridging fluorine. So here no bridging fluorine is present, only terminal fluorines. So each sulfur has 1, 2, 3, 4 and 5 fluorine on each sulfur. So this 5 and 6, 7, 8, 9 and 10. So each sulfur has 5 terminal fluorines. So the statement is incorrect. Next one is S2F10 consists of one SS bond. So here one sulfur-sulfur bond is present. So the statement is correct. So the answer is option C. That S2F10 dissociate to SF4 and SF6, and there is one SS bond in S2F10. The next question is elemental sulfur react with F2 and Cl2 to form. Option A is S2F2 and SCl6. Option B is SF6 and S2Cl2. Option C is S2F4 and S2Cl2. And option D is SF6 and S2Cl4. So elemental sulfur is S8. So S8 react with fluorine to form SF6. So to balance this equation, there are 8 sulfur. So 8 into 6 is 48. So for 48 fluorine, there should be 24 F2. And with chlorine, S8 plus Cl2 will give S2Cl2. So 8 sulfur. So 4 S2Cl2. So 4 Cl2. So the answer is option B. With fluorine, it forms SF6, and with Cl2, it forms S2Cl2. The next question is hydrogen sulfide on reaction with oxygen in the presence of activated carbon resulted in the formation of option A sulfuric acid, option B sulfur dioxide, option C sulfur, and option D sulfur trioxide. So this is the method of sulfur recovery. So sulfur recovery means from compounds sulfur is separated. So 2H2S plus O2 will give on activated carbon. So it forms 2 sulfur plus 2H2O. So the answer is option C, sulfur. Next question is oxygen is more electronegative than sulfur, yet H2S is acidic in nature, while H2O is neutral because option A water molecules are associated due to intermolecular hydrogen bonding. Option B is H2S is a gas at ordinary temperature while H2O is liquid. Option C is water has higher boiling point than H2S. And option D is HS bond is weaker than OH bond. So let's go through each statement. First is water molecules are associated due to intermolecular hydrogen bonding. So this is not a reason for H2O is neutral. So intermolecular hydrogen bonding is due to the higher electronegativity of oxygen. So it polarizes the OH bond. So delta plus and delta minus will be present. In H2S, that polarization is not high compared to OH in water. So that polarizing ability of sulfur is very low. So there is no intermolecular hydrogen bonding. And in second one is H2S is a gas at ordinary temperature while H2O is liquid. So this is not a reason for water being neutral. H2O is a liquid because the presence of hydrogen bonding again. And option C, water has higher boiling point than H2S. So here again, high boiling point is due to the hydrogen bonding. And option D, HS bond is weaker than OH bond. So this statement is correct because the bond formation energy is very low in H2S compared to OH. So it has a weaker bond. So it's easier to break the HS bond to form the H plus and SH minus. So H2S dissociating to give H plus and SH minus is much more feasible than H2O giving H plus plus OH minus. So the answer is option D. HS bond is weaker than OH bond. The next question is the reaction in which oxygen released is in singlet state is option A is 2H2O2 on MnO2 or platinum catalyst giving O2 plus H2O. Option B 2 KClO3 in presence of MnO2 catalyst uh, giving 3 oxygen plus 2 KCl. Option C is H2O2 plus NaOCl giving O2 plus NaCl plus H2O, and option D 2 NaClO3 giving 3 O2 plus 2 NaCl. So the reaction in which oxygen is released in singlet state is option C, reaction of H2O2 with NaOCl giving O2 plus NaCl plus H2O. So here O2 is released as in singlet state. So in all other reactions, it's a triplet. So in triplet state, the electronic configuration is sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px, pi 2py, 2 electron in each, and pi star 2p, 1 electron in each antibonding pi orbitals. So here it's triplet because 2s plus 1 will be 3 because the s is total spin. So there is 2 electrons with half spins. So 2 into 1 by 2 will be 1. So s equal to 1. So 2 into 1 plus 1 is 3. In singlet, so in triplet, 1 electron is shared in both pi star antibonding. But in singlet, what happens is that the electron in 2py is added to 2px. So pi star 2px is filled with 2 electrons and pi star 2py is empty. So here 2s plus 1 equal to 1 because the spin will be 0. So plus half and minus half is present in one orbital. So the total spin will be 0. So 2 into 0 plus 1 equal to 1. So the answer is option C, H2O2 plus NaOCl giving O2 plus NaCl plus H2O. So that's the reaction where oxygen is released as singlet. So that's all for today. If you have any doubt, you can ask.